All right, looks like we are live. Hello and welcome everyone to today's webinar with Atombeam Technologies. I'm your host, Nathan Disk, and thank you all for joining us. We've talked a lot about Atombeam's advancements with Nerpac and PCM in previous webinars, but today we're focusing on an important milestone. Atombeam's first major commercial reseller agreement with Trilliant, a global smart grid communications provider. While Atombeam has previously validated its technology through defense contracts, this partnership represents a significant step in their commercial strategy. Nerpac is designed to improve bandwidth efficiency across existing networks, and through Trilliant, it is being positioned with the smart grid market. So, joining us today is Charles Yeomans, Chairman and CEO of Atombeam. Welcome back, Charles.
Thanks, Nathan. Appreciate you having me.
Yeah. And we also have Julian Dursey, Chief Product Officer of Atombeam, and Jeff Shebb, VP of Product Management at Trilliant. Welcome, both of you.
Thank you.
Today's discussion will explore the structure and scope of the reseller relationship, the commercialization roadmap within the smart grid vertical, how partner-led distribution supports broader market adoption, and what milestones investors should be watching for as the relationship develops. But before we begin, a quick reminder, Atombeam's Reg A offering is currently live on StartEngine, and you can learn more at startengine.com/offering/Atombeam. As always, investors should review the offering circular and risk disclosures in full before making an investment decision. So we'll get the discussion underway, and then we'll leave some time at the end for questions. So if you're watching, please feel free to drop questions in the comments as we go. But with that, I'll turn it over to Charles to kick things off. Go for it, Charles.
Appreciate it, Nathan. Welcome everybody. Good to connect again. I think most of you are pretty familiar with me with Atombeam, or most, I think. But in any case, I'm going to walk through a quick slide on that. But mostly today, it's going to be about what are we doing here? Why are we doing this? And why is it important to Atombeam and important to Trilliant? So it becomes sort of like a question of like, how do you actually go to market with a product like we have? You like with Nerpac. Nerpac is really, it's a way to make other things better. How to make other things more efficient, faster, able to handle more data, all the things that those things need to do. So when you say to yourself, okay, what does that really mean? How does this really turn into something that is, something real and that is used in the world? And it's like that you find potential partners, in this case Trilliant, who can turn it into something that is really meaningful for their customer base, and prospectively other customer bases that they know and want to help us get into. We're not experts in smart grid. We barely know the language. We have a broad understanding of what these are about, but getting into a discussion with a company like Trilliant or Trilliant's competitors doesn't really work. I mean, it can work, but it takes a long time, and there's a lot of education we have to get, and so forth. By setting up this relationship that we have, and mutually, Trilliant and us saw it right away, this could be a really good combination. And the reason why is because there's lots of need for more bandwidth in smart grid. It's a big issue. And so how do you deal with that? We're the way you deal with it. And they saw it right away. We saw it right away. And now we're setting up not only a relationship in which Trilliant is going to be putting it into their networks, but also into the networks of other smart grid providers. And they can have the discussions with those smart grid providers that's a lot different than our discussion would be right out of the bat. They're able to say, oh, look, and talk the language and talk, exactly how it would be used and exactly what the issues are. They know. And so that helps speed our how do we go to market? What it is that we're trying to do, in essence, when you talk more broadly about Atombeam and Nerpac, is get into devices that are then resold to end user customers. because if you're talking about like us going to an end user, then you've got to get over the education hump. Then you've got to convince them that they really, and they may be all enthusiastic, but they don't actually make the boxes. They don't actually design the whole systems. They got to go to their designers of the systems and work with them. So this is a lot better way of doing it. That way, we're going to guys like Jeff, and Jeff can say, this can fit into our system this way. And then he and his guys can talk to their customers and their competitors even about what the advantages are. It's a lot different conversation, and it's a lot more effective, and it'll go quicker. It takes a while to set up the relationship, but we've done it, and we think this is the crown jewel. And we have relationships with Intel and NVIDIA and Viasat and all these other guys. This one is right out of the box, clearly understood by everybody to be a really important way that we can help them and they can help us in turn. And I've talked about this a lot recently. There's a book called Crossing the Chasm that is a really great book, and it really defines, and most people buy it, that how do you go to market is really with a new product and a new vertical. It isn't really a new vertical. It's a new industry in a sense. Is you have to go deep in some vertical. This is the vertical we want to go deep in. That's not to say we wouldn't want to do another, but we limit it, we focus, and we get to be an industry standard. That is what Trilliant wants to get to, is to make Nerpac an industry standard. They make money from it, we make money from it. And once you've set yourself up and you are, a well-known technology in a given vertical, in this case, smart grid, we go to automotive, we go to, to some other like robots or whatever, you have credibility like that. So that means that that's why this relationship is so important, and why we're willing to really go the extra mile to really do everything we can to make it work. So with that, I'm going to turn it over to Julian and Jeff, who are going to talk about. Well, first I'm going to give. Let me pull up a slide here, and I'm going to talk very briefly about Atombeam, where we are at the moment, and so forth. So we've raised, it's including the 30, I think it's 34, 35 million or something in crowdfunding, and then it's actually more now when you include everything. But as Nathan said, we're out doing a round right now. We have about 55 people. We have 7 contracts over time with DoD, and the current one that's running right now that'll we think be pivotal is with Space Force. That will be completed this year. We're hoping to get to a point, and so are they, in which we move to what's called a phase 3, which means that you're getting ready to deploy it. All the work that needs to be done to get to actual deployment of the technology. They want to see it in their satellites. We have 170 patents that have been issued or allowed, and we have another 276 that are pending. And you can see there, we have a bunch of partners. That isn't all of them, but we think of Trilliant as like the most important partner we have. We get awards all the time. We just got another one. Can't even say the name of it because it's embargoed, but we just got another one like yesterday. People get it, what this is and how important it is. But in terms of actually bringing home the bacon, that's what we're focused on right here and right now. So with that, let me turn it over to Julian. Julian's going to talk about, that got a little messed up. Julian's going to talk about where we are, a quick reminder of what Nerpac is, and then and how it's actually used, And then he's going to turn it over to Jeff, and Jeff's going to talk about Trilliant and how they're going to use Nerpac and how, what their business is about. And between the two of them, you'll have some background on what it all is, and actually be able to dig in and answer some questions and so forth. So go ahead, Julian. You're on mute.
Thank you, Charles. I'm on mute. Yes, and I'm very excited about this relationship with Trilliant and the work we're going to be able to do together. Just I wanted a quick reminder to those who are new to Atombeam, and especially the Nerpac product. So the Nerpac product is, we call it compaction because it's radically different from what you would know as traditional compression. Traditional compression will take an entire file and try and organize everything and squish it into a ball and then squish that ball into smaller. What we do with Nerpac is completely different. We take a data stream and we squish that data stream, but the data remains in the same order. So that confers it some very unique properties. So how do we do that? We're using machine learning to very quickly identify patterns in that data stream, and then inform how we can then compact that data stream. And what it means is, in terms of the actual compaction process, it's not as memory intensive as compression. It can be done on very, very small datagrams. So you can take, say, 10 bytes and squish that into 1 byte, and so on. So in terms of the memory, the power consumption, and the processing, it's a much lighter process than compression, and it remains effective on small datagrams, which compression cannot do. If you try to take 100 bytes and compress it, you'll probably get 150 bytes. So it just doesn't work for small elements, which is where Nerpac comes along. And so it's very important in environments where you generate lots of data from lots of small sensors and at a high frequency, for example. And then this data transmission then gets expanded again. The patterns that have been squished into smaller data elements then get expanded. So the whole process is what we call lossless. So every byte, every bit that comes in comes out exactly the same at the other end. And that's what's really important about our technology. Very different, and therefore we call it compaction enhanced Nerpac. So. And then this is an example of our product. When you see the data coming in, we are in here. It's an example of a graph of what's happening when data is pushing through a data connection that's limited at 2 megabits per second. The data initially is limited at 2 megabits per second. Then the system learns from, I don't know if you see my cursor on the screen, but it learns the data patterns and therefore starts encoding it, and that's what you see on the blue line is the encoded data. So that remains at 2 megabits per second, but because we're encoding the data, we can now automatically transfer 8 megabits per second, and that happens completely automatically and transparently to the applications. So the systems that are using Nerpac don't even know it's happening. And then that on the right is the compaction ratio, that the savings you're able to achieve on the data stream. The little spikes that you see on the screen is just that we regularly reevaluate these patterns and then make some adjustments. And in fact, we're making some improvements where you won't even see those spikes. Still, we'll be reevaluating on a regular basis, but you won't even know it is happening. So the benefit is on average we experience 75% reduction in data stream. We just had recently some reports from our partner in Saudi Arabia that they were able to compress Microsoft SQL replication transactions at 70%, for example. So that in effect means you quadrupling on average your existing bandwidth. It's machine learning driven, and it's pretty much near real time. We do this compaction process in microseconds, and it's as I mentioned, it is lossless. Benefit also if you're on a congested network. So typically on radio communications, you may not realize, but when even using 5G, your download is working very well, but if you want to upload data back, your bandwidth would be probably on average 1/10 of your download speeds. So the amount of data you can push back up is actually very limited, which in the situations of IoT and remote sites is very important. They don't need to download data; they need to push data up, and this is where Nerpac becomes highly valuable. Compaction is on microsecond, and we also designed the solution to be transparent inline in the data path. We call this bump in the wire. So essentially, data is passing through. We could squish it. We expand it again. The applications around it do not need to be modified. You only just deploy it inside your network. And as an example of deployment, so what happens, Nerpac is made up of two main components, a controller and an agent that you deploy on remote sites. So what happens is the agent itself is actually very, very small piece of software, and the controller is more like your server piece of software. Think of it working like a VPN tunnel. We call it a compaction tunnel. So what it does, you deploy a client, an agent on the site, like 20 megabytes, uses we deployed, for example, on the home router, and it barely registered in terms of the impact on the CPU and the memory, and it was able to compact data that we transmitted from the home to AWS, for example. So the controller is like your server, and it creates this compaction tunnel. So we squish the data, we encrypt it using TLS 1.3, so it's completely secure. It goes to the controller and gets expanded. That's operation also happens in the reverse. So for example, if you need to send updates, new configuration file, new other things back from your central location to the edges, then your process can Nerpac will do that as well. It will compact in both directions. So it's not just coming from the edge to the controller, but also from the controller back to the edge. And then the controller has all this machine learning engine that learns from the data and then instruct the agents how to compact the data. So the compaction process is specific to each connection because it's specific to the data that is being transmitted. Next slide. And that's it. And I hand over to Jeff. Thank you.
Thank you, Julian. So first of all, delighted to be with Atombeam here today to talk about our partnership and the ways that Trilliant sees Atombeam helping to enable the next generation of smart grids. Really quickly about Trilliant. So Trilliant is a technology and solutions provider to utilities, primarily electric utilities, again, focused on that smart grid space. One of the things that differentiates Trilliant is that we really take pride in this concept of power of choice. And what that means is that we partner with a number of different electricity metering vendors globally. There's probably 4 or 5 major vendors in the United States, many more globally. And particularly after the post-COVID era, what we're seeing is that utilities really don't want to, or they want to diversify their supply chains. So they want to work with many of those meter vendors. So as a device agnostic provider of communications platforms and software, we're able to enable that interoperability and choice for utilities. Move to the next slide here. I'll give you just a few quick statistics about Trilliant. So we connect over 30 million endpoints globally across our customers, managing about over 2.7 terabytes of data on a daily basis. We're a very innovative company, 86 patents and growing. And again, we're partnered with over 60 utilities in just about every continent, I believe. And we've been doing this for the past 40 years. So we know the smart grid space, we know utilities deeply, and we greatly value our partnership with them. So let me tell you a little bit about one of the challenges emerging in the smart grid space, and that is really driven by this concept of AMI 2.0 and the grid edge. For those not familiar with the terminology, so AMI is advanced metering infrastructure. And probably going back into the 90s, utilities rolled out technology called AMR, or automatic meter reading, which was really about just sending wirelessly the regular meter reads used for billing on meters. In the early 2000s, there was the first wave of AMI, or advanced metering infrastructure technology. And what that did was, beyond just billing, it enabled utilities to do some things like remote disconnects of meters, to receive power outage notifications, and to understand load profile, kind of electricity meter usage throughout the day. Now, 20 plus years after this first wave of rollouts, we're seeing kind of a refresh cycle and a second generation of technology, which is about doing even more, extracting more value from those electric meter assets. That covers use cases in helping to ensure grid stability, understand power quality on the grid, manage distributed energy resources like wind and solar, batteries and EV that are connected to the grid. And all of this requires data. So the latest generation of smart meters, AMI 2.0 meters, are very good at generating data. In some cases, sampling that voltage waveform at 16,000 cycles per second. So if you think about millions, hundreds of thousands, or millions of meters in a given deployment in a utility service area, and all of that data continuously being streamed and sampled, that really represents exponential data growth compared to what was historically needed just for meter bills. This leads to kind of an unsustainable choice for utilities. In order to process that data, they can add a lot of compute power there at the grid edge, which is great. You could imagine, in theory, GPUs at every meter, but that adds a lot of cost to the device, power consumption, complexity, etc. And it also locks you in terms of the ability to upgrade that meter as technology evolves. Meters are typically 15 to 20-year assets that are capitalized by utilities. Alternatively, you could try to send all of that data back to the cloud for processing. Certainly that would be more cost effective if it weren't for the constraints of physics and the limited network bandwidth to move that much data. Even with today's 5G cellular technologies, trying to do this in a cost-effective manner to every meter just isn't there. Latency matters in some of these use cases, in particular in terms of enabling the grid to respond to changes and things that are out of balance. So these two choices here really aren't sustainable on their own. And that's where Trilliant is looking at a new way of tackling these problems. We can go to the next slide. So if that's the problem, what is the solution? So I think one of the exciting solutions that Atombeam and their Nerpac technology enables is the idea of truly implementing a distributed computing model, both in the fog, say, in the network infrastructure layer, as well as in the cloud at a head-end system, and shifting a lot of that intensive compute, take advantage of AI and GPUs, but doing it more cost effectively at these higher layers and not at every grid edge device. And the key piece that's missing today is the ability to effectively send that data from the grid edge to one of these other layers for processing. You can imagine a world where meters and other types of grid edge sensors are able to send data instead of every 5 or 15 minutes might happen today for certain things used for billing, streaming it every minute or even less than that, being able to record snippets of anomalous waveforms that are seen and to send that up to higher layers for processing and storage and further analysis. Being able to make decisions autonomously in milliseconds to respond to real world conditions, as well as to be able to provide operational insights to utilities to further improve their reliability. So we think that's really the promise of the Atombeam technology, why we think it could be revolutionary within the smart grid space.
All right. Thank you, Jeff. So just to highlight, this is Jeff and I are working together on how we're going to integrate the Nerpac technology with this environment. And so you can now picture understanding that we compact the data. So, for example, the controller will be sitting on that fog compute element and the agent will be sitting on the smart meter. integrated within the smart meters to compact the data, so data can go up to the smart meters. But there may also be some updates and things that need to be sent to the smart meters. So we're thinking also firmware updates and so on. So it's not just a one-way traffic. It's also down to the meters themselves. So communication with the meters can be very challenging. And then similarly, some of the meters will target directly the head-end system. And so there will also be controllers on the head-end system, which can help also, even with the cellular backhaul, because even though, there's enough capacity, you may also still want to reduce the impact on the network and the impact on the bill if you're having a huge network being deployed.
A quick request here, because I know that a lot of people aren't going to know what a head-ended system is or the fog is. So maybe one of you guys could talk about what that is, please.
Yeah, I can jump in on that. So in terms of the head-end system, if you think about all of these meters and different sensors that are deployed across a grid, the way things typically work is you typically have what are called mesh networks that send data from meter across many different meters up to some level of network infrastructure, kind of collectors or gateways effectively, which then can backhaul that data over a higher speed, higher bandwidth connection like fiber, 5G cellular, et cetera. But there needs to be a software layer back at the utility that is used to manage that connectivity to receive all of that data and make sense of it. And then that data in turn can be used for billing purposes or for feeding various upstream analytics systems at the utility. So what we call an AMI head-end system, it's really the device and network management plane that a utility uses to interface with these meters and grid assets.
Great.
In terms of the fog computing concept, it's just the idea of, not doing it at the edge, not doing everything at the cloud, but truly taking advantage of that network layer, these kind of collectors and gateway devices that are typically pole top and much easier to have, higher power compute. They frequently have battery backup for outage scenarios, and they're typically modular, so easier to upgrade that compute technology as things evolve.
Great. So when you think about what this really looks like in the real world, you've got a city, and the city has a lot of buildings, and the buildings all have smart meters, and the smart meters upload or communicate with, but mostly send data to the fog, right? And the fog is where, as you said, the collector bringing all that in. And where would Nerpac sit in this whole thing? On the edge, which is in the devices, in the fog, in the head end, and everything?
Yeah, I think potentially all of the above. I think you need some type of agent at a grid edge in order to establish that tunnel back to these gateway devices. But some data you may want to go ahead and send to the cloud as well. So that would mean sending it from the gateway up to cloud analytics. Maybe it's snippets of data, particular anomalies or event driven that you want to be able to analyze more deeply. So really potentially it could live at all of these layers to facilitate that connectivity.
Great. And so how hard is this to integrate? That is to say, to start using, could you use it tomorrow, or would it take a month or whatever? Give us a sense of the timeframes and so forth. I'm Mr. Investor out there, or Mr. Learning about what you're doing, because it's really easy for me to take this role since I kind of learning myself. So,
yeah. So Jeff, what do you think? So we already have this compaction tunnel. So we, in terms of compute requirements, etc., definitely going from the gateway in the fog back to the head-end system, that we can do that pretty quickly. We'll have to obviously validate and make sure it's all working, but that's not going to be the biggest benefit. And then we're having also discussion on how we're going to integrate the agent into those smart meters. The benefit is the agent is very simple. It just does encoding and decoding. It doesn't have this machine learning aspect, for good reasons, because we don't want to have any sort of strong compute there. And as I explained before, it's the encoding and decoding is actually very simple. It gets given a dictionary, what we call a code book, and looks at patterns in the data. When it is a pattern, swaps it, and then sends it on. When it receives an encoding stream, sees the patterns from the, swaps it with what it has in the code book, puts it back, and then the data stream is restored. So in terms of compute operation, that's very simple. What we do need to do is work together with Jeff and understand so there's a technical integration that we need to do. So these devices, the smart meters, they don't use the same compute requirement that you would have on your PC at home or in server. So it's a different type of compute processing, and we just need to do that adaptation of that process. But the process, as you can imagine, is relatively simple.
Okay, great.
Yep, agree. I think the technology is well proven. Now it's a matter of adapting it to the type of constrained hardware that exists in the meter, kind of validating that concept and then building it into Trilliant's next generation of products. So I think we're very excited. I think there's been some proof of concept work done already, and looking forward to continuing that exploration and making this a reality within the smart grid.
Great. So Nathan, do you want to kick off? Do we have any questions or?
Absolutely, yeah. So I'll just toss some questions out, and then maybe you guys can kind of jointly handle them depending on the topic. But first question here is, can you clarify the scope and structure of the Trilliant reseller agreement? Does it include minimum purchase commitments, exclusivity, or performance milestones?
Those are good, excellent questions. So it does include, it is exclusive for smart grid, and we had a hard time going through and trying to figure out exactly how to calibrate it. There is an agreement that, for the first couple of years, we don't have specific requirements for sort of the amount they sell or any of that stuff. So we are basically at a point where we say, all right, now we both have better knowledge of here's who's buying it, here's who's, from Trilliant's perspective, who they're able to get to, the market and get that market to start using it. And down the road a little, we're both going to have a pretty good sense. And then, yes, and at that point, we are establishing this is the target you got to hit for next year. And if they don't hit it that year, they get another year as a grace period. And then after that, then we have the ability to, at Atombeam to terminate the relationship or terminate the exclusivity, put it that way. The exclusivity really is to say, we're counting on you guys to go out and sell a lot of this, and that is the belief on the Trilliant side. And so as a result, but I should say, before I say as a result, but we don't jointly know what that looks like yet. And so there is exclusivity. There is going to be performance requirements. We don't know what the performance requirements are yet, but we will establish those as we go. And Jeff, if you want to add anything, feel free.
No, don't think anything to add. Again, I think we're excited about the potential of the technology. I think Trilliant's uniquely positioned given our relationships with all of the major meter vendors and our belief in the power of choice to really push this in, not just into Trilliant products, but more broadly into the industry.
Right. So that was a big part of how we think about this, because in terms of Trilliant as a partner, they're very much sort of like open architecture, open, you don't have to use their stuff, unlike a lot of their competitors. You don't have to go, say, use, competitor X's, smart meters because they believe in having it open. And that is exactly right for us in terms of setting up what is a great partner for us. This is exactly the kind of partner because they can talk to anybody and anybody can use the stuff, the same equipment. So from our perspective, it was the perfect idea, just like it was for them. So by the way, Nathan, I think we can stop using the slide. So.
Oh yeah, let's go ahead and pull that down. Great.
So go ahead, next.
Yeah, next question. Let's see here. So I know you guys spoke a little bit about this, but we got a live question regarding it. What does the implementation look like from a timeline standpoint? And is that something that just gets installed or downloaded as a software? It sounds like maybe a little bit of both. Maybe if you could expand on that.
Well, that's you guys.
I mean, it is.
Go ahead. Well, so from my perspective, this is something that is definitely an ongoing innovation exercise. There's multiple things that have to be developed, right, in terms of validating the ability to run this software and run this agent on the very constrained meter hardware. And then there's also development ongoing for a next generation of gateway that can host this controller software. So this is something that is certainly not years off, but I think over the next year, there'll be quite a bit of active work done to develop and validate the concepts. So I would say it's not something you're deploying tomorrow, but hopefully in the near future.
Great.
Yeah, and I think, with Jeff, we'll work also on ways to do proof of concept trials with customers and simulate that with the existing environment. I mean, we could already start looking at going from the fog back to the head-end system just to see on the data itself what's happening, which will then be a good reflection that what will happen to the other meters. And there may be some customers who are interested in reducing their cellular bills, for example. That might be one thing that we want to do. What we're saying is there will be some customers who will be interested in that, not all of them. The meter bit, that will be everyone will be interested in. Well, I'm saying, pretty much everyone will be interested in that. So that's really where it's more important. It doesn't mean that we're not going to do things in the meantime, which will help us put some milestones towards, understanding and validating the value proposition that we'll bring to customers.
Yeah, it'll be a phased approach, and I think identifying, utility partners will be key as well to validate this in, utility proof of concepts and utility field scenarios. As utilities in general, a very conservative industry, so they generally like it when someone else goes first. So I think having a partner to kind of co-innovate and validate with will be helpful.
Absolutely. So next question here, given the size of the market, like 1.8 billion smart meters globally, what percentage penetration would constitute a meaningful commercial inflection point for Atombeam?
Part of what my hesitation in answering that in any kind of precision is the fact that neither us nor Trilliant, and remembering that there's a revenue share here, so Trilliant makes as much as we do out of whatever it is. Neither of us is really sure exactly how much we're going to charge. I don't want to go into too much detail here because we have really specific ideas, but we've got to do some market testing and so forth, which means that, the net is if we think about what's a meaningful number of meters in which we get a meaningful amount of revenue, and it's going to be something in the millions, and like say for 5, 6, 7 million meters, we might there might be 3 million or 4 million of revenue, but I'm throwing those numbers out, but I really don't have enough data yet to give you a really good sense. maybe Jeff, you could talk about how big some utilities are versus others, and kind of,
Yeah.
how this might work, how it might actually fall out. That somebody says, okay, Southern California Edison says, "Do we like this?" Well, what happens?
Yeah, I mean, you have, your very small utilities, of thousands, and then obviously the big boys, investor-owned utilities within the US, like your Southern Cal Edisons and your Duke Energies and such, that can be, millions of endpoints. A lot of it has to do with intersecting with AMI refresh kind of technology upgrades as these utilities. Some utilities, deployed 20 years ago, and they're looking to deploy new technology out there. Others were later to the game and so aren't at refresh. So typically, for those big ones, you have a few opportunities a year. They're kind of a multi-year sales cycle for these large refreshes, and then deployed over a number of years. I think that, there's a lot of interest out there in what can be done with this grid edge intelligence. And this certainly is a technology that can help facilitate that. There's still a lot of questions of how to value different grid edge app use cases, but collectively this represents a major potential source of value and operational improvement to those large utilities.
And maybe you could expand on that last thing you were saying, that how important is this? If you're talking about AMI 2.0, and you're talking about the other things that are trends in the industry, maybe give a sense like, okay, this is really important, or it's a nice to have, or whatever, some sort of indication that how you think it would be received when you sit down with this one or that one.
Yeah, I think it's a potential game changer in that, utilities are looking at making their choices now, and in many cases, having to bear that extra cost in every meter, but they're already concerned about lock-in in terms of, okay, what about when, 5 years from now, 10 years from now, there's even greater, GPU technology that could be harnessed, and now I have this asset out there. The one thing that is very clear is that the amount of data utilities are wanting to glean from the grid edge is not, shrinking. It is growing, and it is growing exponentially. So whether that's in moving that data from the edge, or even storing parts of it more effectively, for further analysis, the amount of data growth is high on utilities' minds as they try to build their rate cases to their regulators, because especially here in the United States, these investor-owned utilities can't just go and spend money. Their business model is such that they invest in infrastructure and they earn a certain rate of return, but they need that rate case to be approved. So they want to extract this value, but they have to do it in a cost-effective manner, as everyone is sensitive to affordability these days.
Right. And how constrained are the networks they use?
Yeah, so when you're talking from a gateway down to a meter, it's typically using mesh networks that are operating in the tens to hundreds of kilobits per second, and this data hops from node to node. So you may have multiple layers of meters and nodes kind of underneath the gateway. Maybe 3 to 8 hops is pretty typical. And there's advantages to that, being able to route around a given failure point, but it adds latency and it reduces your usable bandwidth.
And what you're saying is, like, you might have a bunch of meters, and then those meters have to send their information to another bunch of meters.
Exactly.
And then another bunch of meters, and then another. And
exactly.
You can imagine how clogged everything can get when you're talking about a network that can be as little as 10, kilobits, per second, which is a very, very, very slow network. Like, we're used to, in our, what you use in your house with your Wi-Fi, what everybody's on right now is like, that's, a factor of literally thousands of times faster than what we're talking about. So go ahead, Nathan. Thank you, Jeff.
Yeah, definitely. We have a lot of live questions, so I'll try to get through as many more as I can.
And
Let's.
by the way, so Nathan is going to give me any of the questions we don't get to, and we will provide we'll do an update answering those. So just so you know.
Yeah, definitely. So this one comes from a live viewer. Presumably, Trilliant must have done an assessment of their end customer interest in Nerpac. If so, can Jeff share the results of that? And has Trilliant started to market it?
Yeah, so what I can say is, yes, we've definitely started to market it from the standpoint of we spoke about this at a large show recently. There's a trade show called Distributech, which was held in San Diego this year. That's where we kind of first talked about this partnership, and think garnered great interest there. It's where a lot of the large investor-owned utilities from North and South America attend. So I think that process has begun. Like I say, there's definite interest. We're speaking to some utilities, individually. Like I say, we're still a little bit early in terms of the commercialization of this, figuring out what that looks like. But from kind of a technology roadmap perspective and presenting the vision and understanding the value to utilities, I think there's definitely great interest in how this will unfold.
Yeah, no, absolutely, Jeff. And in fact, I was attending Distributech. I was hosted on the Trilliant booth, and they're asking me to present it to their customers, but also on these little plenary sessions that they have on the big screens and things. And I'm also, with Charles and I will be joining Trilliant at the Tech Advantage show in Nashville as well, where we will have a demo stations and where we'll be presenting the technology. So I definitely can confirm that.
Great. Next, move on to the next question here. Does the local utility company make the decision to install these smart meters? Is there still room for growth in that market? And maybe touch on a little bit of the market share that you already have.
Yeah, it's definitely a growing market globally. I don't have the figures to cite with you here, but they're actually pretty easily obtainable. There's differences between different regions. What you're seeing is that the North America region, right, which kind of led in that first wave of AMI deployment, is leading the way in this second wave, this refresh cycle, which it has a lot of the focus on this grid edge intelligence that's driving a lot of this data. In other parts of the world, you're probably 5 to 10 years off from that happening, and they're still kind of going through AMI 1.0, so a lot less data, a lot less of a problem, but it's coming, and North America is leading the way. Parts of Europe and pockets of Asia are right in there as well. So it's definitely a growing space. One of the things probably holding it back again is that need for utilities to get their rate cases approved, which means understanding the cost and benefits. And I think right now there's it's probably moving a little bit slower because they're struggling with that cost benefit justification. So anything we can do to help lower the cost, to help take advantage of this data more efficiently, will help accelerate that rollout.
Thanks.
And Julian, this one might actually be for you. So we've talked a lot about data compaction, but this question asks, how does the data get uncompacted?
Yeah, it's a reverse process. So when we take the data stream, it's all these, what we call the encoded stream. So if you imagine you have a dictionary and you have an index in your dictionary, so word number 1, word number 2, word number 3. So instead of sending the whole word, we just send 1, 2, 3 instead of the entire word. And then when we see 1, 2, 3, we replace 1, 2, 3 with the corresponding word in the dictionary. So that's how. So the two processes are exactly the same, just a mirror image, if you like. The clever bit around the compaction process is not so much the actual process of encoding and decoding. That's very well known. It's been known for a very long time. It's called dictionary-based compression. But it's how we detect those patterns very quickly and turn that into very efficient encoded 1, 2, 3s. Which one would be number 1? Which one would be 100? 100 would be longer than the 1, for example. So that's why you have to very quickly decide which one goes first, which one goes last, and then that's where our clever bit. In reality, it's never been used, because if you were to use that for long patterns and things, in theory the dictionary would explode. You would need terabytes size dictionary. We are able to create a very, very efficient dictionary just in like 1 megabyte, even for long patterns, and that's where the science. It's all proven by Professor in mathematics from South Carolina, our chief scientific officer. But yeah, so that's really our secret sauce, really.
And I could add to that, like one of the things that's really critical is what Jeff was touching on, which is these smart meters are not exactly like a powerhouse computing platform, right? They've got cheap, I don't mean cheap, like inexpensive processors in them. And those are not very capable, and otherwise they'd be too expensive. And so you put out literally millions of these things, and you can't expect them to even run compression, because compression works differently than compaction does, than Nerpac does. It does a lot there right now on that file. It looks for the repetitions of pattern, replaces them where it finds them in a code word with a placeholder that replaces that particular repetition with a little placeholder that says, when you put this back together, go get that pattern over here. That uses more juice, and those meters probably don't have enough. And so this, what Julian's describing, is called a lookup. It's called a swap. And so it's about as light and fast as anything can be in computing, which means that even these, very low power, smart meter processors can actually do what we need them to do, which means that, when you're talking about Nerpac, you can put it in anything, in effect, because it doesn't need much of any compute power. It really changes the game in terms of thinking about where you'd use it. And again, that's another thing that Trilliant saw right away when they were evaluating Nerpac and its potential use. It's not doing the same thing that compression is, and it's possible to actually use it in a smart meter. But go ahead, Nathan.
Yeah, next question is regarding competitive positioning. So what alternatives do utilities currently use to address bandwidth constraints in smart grid networks, and how does Nerpac compare in terms of cost, implementation, and complexity?
Good question. That's it. Jeff, go ahead, please.
Yeah, what I'll say on the competitive technology pieces, right? So I think today, primarily what is deployed out there is this AMI first generation technology. So they're really bringing data, much more limited data back, maybe 15-minute interval, they call it data, and you do that maybe once every hour. So 24 reads a day. It's not a lot of data. The ones at the cutting edge are beginning to see signs of more data, but we're still very, very early in the deployment of this second AMI 2.0 technology. A lot of utilities are beginning to deploy the meters, but not the apps that are actually generating the data. So I think what that does, how that limits their the use cases they can realize, and or require adding more network infrastructure. So think more gateways, aka more cost into the network to improve the bandwidth. I think that's the trade-off they have right now. So I think there's not great other technologies that solve it in quite the same way. It's really a matter of throwing cost, either more cost in the meter, more cost in the network to improve the bandwidth. And again, we have only begun to make use of all the data that is available to us.
Great, thank you.
Great. Yeah, we're just about done. I know, so in the live chat, I know there's a lot of questions regarding the timeline and the milestones and things like that. I know we discussed it a little bit, still early on in the relationship. If there's any broader context, I know, Charles, you'll likely be keeping the community updated as you go, as we progress through this relationship.
Yes, of course. I mean, and yes, quite a lot of evaluation work, thinking through things, discussing things like, what does a contract look like? What is, how do we formalize this? How do we decide on things like how, what's the price? I mean, it's one of the things that you encounter when you're talking about a new technology that doesn't have any precedent, that doesn't have anything. It's not a better refrigerator than the one you got. It's some other thing. And so how do you price it? What is it? How does it fit? And as you're hearing from Jeff and Julian, it's not as simple as, okay, here's the Nerpac thing, stick it in the meter, and then now we're ready to go. It's got more things to do, because it's, as Julian said, it's a bump of the wire. It's a inline technology that needs to be integrated and needs to be tested, within that integration. I mean, yeah, it's been tested very, very extensively, right? But this will be true for virtually every deployment we do, like the one with Space Force that we're, probably going to be starting to work on later this year, is only, going to really happen when we really dig in. Here's their processor. Here's how much RAM is available. Here's how much other resources are available in the system that they have. And then we got to adapt Nerpac around those constraints. And so all I can say is, like, yeah, I will keep everybody informed as to how it goes, but I've tried to make everyone understand this is going to be true every time. The cool part is, it's not like a lot of things where I make a sale and then I've got to start from zero and make another sale. This is like, we do all this work and now we've got it working in these meters. Now Trilliant, or somebody else that they sell the combination to, will be able to deploy it in a million or millions of smart meters at once. So again, you go and you buy a refrigerator. Now you've made a sale of a refrigerator. Now somebody else has to start from zero and decide they want to buy your refrigerator. In this case, no. I mean, it's integrated, it works. We have an order, or really Trilliant has an order, and it goes like, boom, now you've got a million meters out there with Nerpac in it. So it's high leverage, but it's also a lot of work in the front.
Yeah, so a lot of work up front and then kind of exponential. Makes sense. Well, I think that's about all the time we have. Maybe I'll just ask Charles, Jeff, and Julian, thanks again. Is there any parting words about the relationship?
You guys have anything you'd like to say?
I think it's been great. I mean, we signed a contract just a few days before the Distributech show, and I went there, and the welcome was fantastic. And everyone I interacted with at Trilliant I can confirm, was really excited about the technology. So, I'm really, really excited about this relationship, and working with Jeff is fantastic.
Yeah, likewise, enjoy Julian's partnership, and I think this has the potential to be a very disruptive technology within this space.
Absolutely, very exciting. Well, thank you again. And another quick reminder: Atombeam's Reg A offering is currently live on StartEngine, and you can learn more at startengine.com/offering/Atombeam. As always, investors should review the offering circular risk disclosures before making an investment. But with that, we'll close it out. Thank you so much for taking the time out of your days to watch this. And thank you, Charles, Jeff, and Julian, for joining and giving us all this great information.
Yep. Thanks, Nathan. And thanks, everybody, for tuning in.
Thanks all. Bye.
Thank you.